Okay, let's talk about containment and destruction of pathogens, which is the second process of inflammation. Here we see skin with a break in the skin, our wound that the inflammation is responding to. And as you'll notice, I've drawn a big circle around the wound. This circle represents what's called a fibrin capsule. Fibrin, if you'll recall, is activated from fibrinogen by platelets. So the platelets that are here responding to the wound activate the hemostatic pathway and turn the fibrinogen into fibrin polymers. And the fibrin polymer would, if it were allowed, form one giant clot here. But one giant clot would actually make it very difficult for our white blood cells to be able to encounter and fight the enemy because they would be struggling through all of these polymers. So mast cells, which are also found in the tissue, secrete something called heparin, which is an anticoagulant. Heparin prevents the fibrinogen from turning into fibrin, and it's active in all of this space. But outside of where the heparin is secreted, the fibrinogen turns into fibrin, and it creates a capsule that surrounds the entire infected area. If you ever get a wound and you notice as it's healing that it's puffy and red, but if you squeeze it a little bit, it almost feels like there's a ball underneath. That ball is the fibrin capsule. And you don't want to squeeze it because if you do, then all of the bacteria, all of the pathogens that are inside that fibrin capsule can actually come out and enter the bloodstream and spread to other parts of your body. So that's why it's best to leave it alone. Now, in addition to activating the fibrin pathway, platelets also begin with phagocytosis. So they're destroying or eating the bacteria or other pathogens that have made it in through the wound. In addition to that, neutrophils, which are the most abundant of the circulating white blood cells, are usually the first to show up at the scene of an injury. And like platelets, they participate in phagocytosis, so they actually ingest and destroy bacteria. But neutrophils do something else that's very powerful. They have something called a respiratory burst. And the respiratory part comes from all of the oxygen that you see in the substances that are part of the respiratory burst. But the neutrophils, remember, they're granulocytes, so they have these granules full of chemicals that can be released. And what they release is a superoxide radical, which is very reactive, and it attaches to things, to pathogens, and makes it so that they can't function. Peroxide, the same hydrogen peroxide that you buy at the drugstore, and hypochlorite, which is also known as bleach. So neutrophils secrete the superoxide radical, hydrogen peroxide, and bleach. And those substances diffuse throughout the fibrin capsule area and destroy not just pathogens, not just bacteria, but also any of our own cells that are in this area, including the other white blood cells. Natural killer cells are also on the scene because they're everywhere, and just like we talked about them killing foreign cells or cells that don't have the right ID, using perforins and granzymes to poke a hole in the cell and destroy it, which we call cytolysis or cytolysis, means the cell bursts or is destroyed. So all of these things are happening in this contained capsule, and the enemy can't run away because of this fibrin capsule. Macrophages and lymphocytes have been called through the mobilization part of the pathway, and so they're on their way, and when they get here, they will also join in the battle. And what happens after all of this is done, after this battle has been raging for a while, is that the bacteria that have been killed, the cells, our own cells that have been killed, the white blood cells that have been killed, all of those together produce something called pus. So if at this point you actually squeezed the fibrin capsule, there's a good chance that all of the dead white blood cells and the dead injured cells, and even the bacteria would come out in this thick white goo, which is known as pus.